There it goes. So rules for addition with real numbers with like signs. Part A. So basically, if they're the same, for example, obviously, if they're positive, 5 plus 5, we keep the absolute value, becomes 10, right? Now, if they're negative, we take the absolute value, but keep the sign, so it just becomes more negative. That makes sense? So if they're the same sign, they just get bigger. They just stay whatever they were to begin with. Okay. So it's easier if they're the same. So add their absolute values. And use the common sign, the one they have in common. You guys see this okay?
No.
No? What's wrong on your side? The blurry or? All right. Is that better or worse? See if I can focus it a bit. Worse or better? I can't tell from my side. It's okay. All right. So let me know. I'll adjust it. All right. To add two real numbers.
At the use the
Where?
these
Part B. Use the common sign. That's the word the right here. Common sign. I'll try to write slower because it is a little messy there. Maybe bigger, right? All right. What was I? Okay, so part A, number 2, subtract their absolute values. So basically what I mean is the smaller from the larger. And part B, use the sign of the number with the larger absolute value. Okay. All right, so let's do the example in just a second. The book they call it example 3. I guess it's the third example in the chapter. I don't know. Who cares? So we're doing that guy over there. Add. So -3 plus 2 plus a -5. You can rearrange them however you want, as long as you keep the right symbols, right? There you'll be fine. So the rule usually tells us to do left to right, but it doesn't matter because it's all the same operation. How do we deal with these two? -3 plus 2. Let's do 2 at a time so we don't mess it up. And if you're ever in doubt, draw the number line. That way you can make sure, okay, am I in the right place? That's like, if you use the number line, you'll always have it correct. But we want to try to get used to these rules, okay? Now, it says subtract the smaller from the larger. If you look at these. And then you keep the sign of the larger one. So just ignore the signs. You'd say 3 minus 2 is 1, right? Keep the sign, it's a -1. Does that make sense? That's all we're doing. Okay, so this part right here becomes a -1. And you have to be able to do this on paper now with calculator all the time. Okay, eventually they will not be numbers. Right. So now they are the same symbol. So they just become more negative, right? -1 plus a -5 would be yeah. So that would be the first rule up here, the first notes that we wrote. Does that make sense? Does the rule for adding and subtracting signs make sense? Like, I know it's basic, but a lot of people mess this up. And if you've forgotten, this is the time to figure it out, right? If you don't remember, or if you rely too much on calculator, it's time to pick it up, okay? Any questions on the first one? Okay. Let's do part B. 6.0 plus -4.3 plus -1.5. Left to right. These are different signs. So subtract the bigger from the smallest, or by the smallest. So what's 6 minus 4.3? What's 6 minus 4? What's that?
2.7.
It's close. 4, if you do 6 minus 4, that'd be 2, right?
Oh.
So lose a little bit more. Do you agree that would be 1.7? Right. So we would keep the sign of the bigger one, which is positive. So subtract these, keep the sign of the bigger one. Stays positive. Is it bugging you?
It's bugging me. 1.7.
Well, let's think about it this way, right? I can write on this guy. What have we broken in pieces? Oh yeah, we'll wait for that one. Now you go. I'll just let you know. So I could say, if we think about that for a second, you agree that this is less, right? 4.0 less than 4.7. So we subtract those two, we would have 2, right? So I have an extra piece to subtract a little bit more. You see where we're going with this? All right. So it has to be on the door. Oh. Okay, so we keep the positive. Now, same deal. 1.7 minus 1.5. And we keep the sign of the biggest one, which is positive. Now, if we remember those rules, we will always have the right sign. Okay, it'll be good. But if you ever forget the rule, you could just draw a number line. Start at 0. This is more work. I don't recommend doing this for all of them, but you can. So if I do -3, I'd go over here, right? If I do +2, I'd end up back here, right? This is -1, 2, 3. So -2 would get me from 0 to -3. +2 would get me back there. -5 would get me down to 1, 2, 3, 4, 5. Does that make sense? The -3 first gets you 1, 2, 3 spaces. +2 gets me back over there. -5 gets me all the way to here. So you can just kind of see where you're at if you're ever unsure. But this is a lot of work and takes forever. So just remember the rules and you'll be good. Okay? But you can check yourself if you want, if you're paranoid. Okay. Anyway, try these two. Using the rules that we just wrote, no calculators, just try it out. Okay. What's that, man? What did you guys get for the first one? Let's start with, is it negative? Yeah. Yeah, it is negative. Yeah, just trust yourself, right? We don't need to check it. Is it, what'd you guys get?
-5.
Yeah, it's -5. Gotta believe in yourself, right? All right. What about the other one? What'd you get? Or B, is it negative or positive?
It's
I think it's gonna be negative. Yeah, you so the first two, right? You added them and then you keep the sign, right? That's what the rule number one says. And then you subtract the bigger by the small one and keep the sign of the biggest. So it should be negative. Yeah, everyone get 3.6? It's not too bad, right? Any questions on those two rules? It's just all we did was just two rules. That's it. Okay. A was -5. All right. Let's move on. Now it's more about concepts. Do you understand those rules we wrote down? You zoom in a bit. It's number one, true or false? The sum of a positive number and a negative number is always positive.
That's false.
That's false.
We went over the first problem.
Yeah. First problem contradicts that, right?
Okay.
Yeah, whenever you're trying to disprove a statement, you just need one example for it to be false. Especially when they make an absolute statement like that. Absolutes better be, backed up. Always positive. Whenever someone says always anything, like it better be a hard evidence, proving that statement. Okay, especially in math. But in real life, nothing is really always, right? It's pretty rare. But okay, number two, when adding two numbers with unlike signs, so different signs, right? The result uses the sign of the number with the larger absolute value.
True.
Yeah, that's what the definition said, right? True. 3, the sum of two positive numbers can equal 0. Yeah, there's no way, if they're both positive, they can never go to 0, right? Because 0 itself is neither positive nor negative. So we said last time. Because so we can't use the example of 0 plus 0. Okay. Alrighty. Is number 4 positive or negative?
Positive.
Number 5? Oh, what about number 5? Negative.
Oh. Yes.
Which one, number 4? I like the confidence though. Okay.
Wait, sir, do we put the answer, or do we just put that as positive?
Put the answer. But if you know if it's positive or negative, you're kind of halfway there, right? Okay. Here we go and write them down here because the recording can't see that other screen without sharing. Number 4. What'd you guys get?
Oh, five.
They keep the sign of the biggest one, right? Okay. Number 5. What'd you guys get? Yeah, keep the sign of the biggest one. So you do biggest minus small. 8 minus 2 is 6. Keep that sign. Okay. Guys do the fraction? Let's hear. You guys love fractions, right?
What'd you say?
You finished the fraction?
Yeah.
What'd you get?
I'm gonna say it's over 9.
No. All right. Let's see where we went wrong, right? It's close. Said 6 over 9? Should be 3 over 10. 3 over 10 is the answer. How do we get there? That's what this is about, right?
Would we simplify that?
We need the LCD in order to add them. Right now we cannot add them. They're not the same. Yeah, we need the same denominator on the bottom. Least is the best. So what is the LCD of 6 and 15? 5 would be, yeah, 30 is going to be the smallest number. Let me do it on the next page. You guys cool on this page? Need more space. So what I recommend is to break down the factor the denominators into primes. That way we can see, okay, how do I make them the same? What are they missing? And when you make them the same, it will be 30. 2 times 3 is the prime factors of 6. 3 times 5 is the prime factors of 15, correct?
Yes.
Okay, you guys with me up to that point? Now we're just breaking down the numbers. That's it. So now they both have a 3, right? So that's great. This one does not have a 2. This one does not have a 5. So introduce what they need and that's it. Okay, you'll be done. Because they need to be the same. So force them to be the same. Does that make sense? This is not overcomplicated. This guy needs a 5. So put a 5. This one needs a 2. Now they have the same exact numbers, right? 2, 3, 5, 2, 3, 5. Which is, what is that? 30, right? Which we already knew. But if you didn't, you found it anyway. You see what I mean? So here we go. 1 times 5. 2 times 3 times 5. 7 times 2. 3 times 5 is the same deal here. Now we're ready. But the important part is this step here. Does this make sense? And this is the time to ask questions. From here to here. You guys cool? You guys all pros at fractions? All right, that's great. Let's give you an exam with nothing but fractions on it. Should be fine. Okay, so what do we do next? What's the answer? Do we mess with the 30?
Oh, wait, what? No.
So we only mess with the numerators. Okay. So just pretend there's no 30 down there. What is negative 5 plus 14? So we have 9 over 30. Yeah, that simplifies to what? If you don't see it, break the 9 and the 10, or the 30. 3 times 10 is 30. 3 times 3 is 9. And that's it. That's where they got this guy.
3 over 10 is -2.
Yeah, so you have to get the common denominator. The easiest way to spot it is just to break down whatever's down there into prime numbers, and then introduce whatever they're missing until they are exactly the same. And then once they're the same, add or subtract. That's it. So any questions on any of these steps? Okay. Yeah, I can't tell if it's super hard or easy. You just gotta tell me. Okay. Let me know. All right. Let's look at number 9 here. Let me see if I can share the screen this time. So slow when I do this.
Wait, we're not doing 8?
Nah. Let's do 9. Oh, did you want to do 8? We can.
Is there a difference?
Let's look at it. This one, right? So do you remember how to deal with the absolute values? So what does it do to negative 5?
Turns into a positive value.
So it's just 13 plus 5, 18. So it's not too bad, right? That's it. Yeah, just remember what do the bars do, and then do it.
That's what it was like.
Yeah, I'm sorry, I didn't mean to skip it. Just forgot. Number 9. Let's see here. Okay, so in 2017, some random business made 45K in the first quarter, lost 8K in the second quarter, another loss of 2K during the third quarter, and then made money again, 15K in the fourth quarter. Okay. So just write down the positive and negatives where they belong. That's it. So the first one is a profit. So you agree that number 9 should be 45,000 to start. And then we can think of it different ways. You can just say plus a negative if you want, or you could do minus. Right? Yeah, let me switch back. You guys have that page anyway, right?
Yeah.
Okay. All right, so 45,000 plus a negative 8,000. And then plus another negative. And then they added more profit. Okay. So that's the same as saying this, if you prefer. That is all the same. Right? You can deal with either one now. So what'd you guys get? Yeah, it looks like positive 50, right? Okay. You can ignore the zeros if you want, and then just add it later, because it's all the same. 45 minus 8 minus 2 plus 15. They're all in thousands. You could if you wanted to. Okay. So part A was just write the equation. This is part B, but it doesn't matter. As long as you understand what they're asking. Okay. So diving will be negative on number 10. So I dive 250, then go up 75, and then diving again 100. Am I still underwater?
Yeah.
Yeah, we're still negative, right? So number 10. Negative 250 plus 75 minus 100, then submarine explosion. What do we get? Negative 70.
Oh, negative 200.
Yeah, that sounds right. Excuse me. Feet though. Okay. Is number 11 possible? And if so, can you think of a scenario? Not possible? Or it is?
Yeah, I think positive and negative of the same number.
Right. And
If you had positive, they would become positive again, right? But they'd have to have absolute values on them.
You could put a negative sign, which makes it a negative. Like on
so
that
like
side.
-5, and -5.
So you would say absolute value of -5 plus absolute value of -5.
-5, absolutely. Is it?
Absolute value.
I would put
I
negative-
was gonna say, right, absolutely. And then what? Yeah,
Negative 5.
-5, yeah.
Yeah.
Well, then that would be negative 10.
It would be negative
No.
2.
That would be.
I mean, 0.
Okay, so you can be doing -5,
No, if we write it out, right?
so -5.
Yeah, plus,
Yeah.
plus, and then negative.
no.
The negative sign, and that was the-
It says the sum, right?
Yes, but can you-
So you cannot put a regular 5, a positive 5?
It says they both are absolute values.
Oh, no. Right, yeah.
Yeah, the requirement is that they're both in those bars, both numbers, and it's a sum. That's what number 11 says.
So we have to put a negative outside of that.
No, not since, not because since they said sum, no. So is there any numbers that would work?
0, 0?
0, 0. That's the only one. Feels like cheating though, right?
Yeah, it doesn't feel right.
But it works.
Cheating.
It works. That's the only case. So yes, it is possible, but it's not interesting. Right? It's just like,
Why is that even? Oh. You be able to leave 8.1 open.
when did it close?
It didn't close yet. Can you extend it?
I'll check in a little bit. I'll let you know. After, when it's time to do homework, I'll think about it. Okay, number 12. Describe in your own words the condition under which which the sum of two integers will be 0.
Negative 1 positive 1?
Yeah, as long as they're opposites, will be good, right? That example.
Yeah.
That's what you were thinking.
Yeah. Okay. Let's work on 1 through, let's see. 1 through 7.
Say what?
Work on 1 through 7 with no calculators, because that's not no calculators. We're trying to learn the ideas of behind the signs. Okay.
I'm doing 8.3.
Yeah, we're doing 8.3 in a bit. We'll give you guys 15 minutes to take a break and finish 1 through 7. Okay. Need a break now, feel free. Okay, this is 7. 7 over 14 plus negative 15 over 28. Break down the denominator. Yeah, they both have a 7. This one does not have a 4. But if we break it down further, just to make it more obvious. So that 4 can be broken down, right? Because we said to go down to prime numbers. So it's better to go down to prime, that way we know exactly what's missing. This has a 2 and a 7. This one has a 2 and a 7, but it has an additional 2. So this guy needs a 2. See what I mean? So introduce, so you only need to change one of them. This one needs 2 over 2, and they will be the same. Right, 227, 227. We're good. So that will become 14 over, what's 2 times 7 times 2?
14.
14 times 2.
Oh, wait, no.
2 times 7 is 14. Like 14 times 2 is 14.
Yeah. You just didn't finish, right? That's all. Okay. So now we have 14. So now we just mess with the top. 14 plus a negative 15. And we keep the sign of the bigger one.
Is this like the long way? There's no shortcut to it?
I mean, I could show less steps, but
I kind of skip some steps.
Yeah, me too.
yeah, I mean, I could do it in one line, but that's not helpful. You know what I mean? I need to show the steps so you can see what I'm talking about. But if you're asking like how many should you show on a test, show enough to convince me you know what you're doing. Yeah.
So if I didn't do your answer,
Give me an answer, I'm gonna give you almost no credit.
So you want, like, the whole, like,
I don't care about the answer.
You want the process when it comes to the test?
I'm gonna grade process, not the answer. So if your answer is wrong, but your process is pretty good, I'll probably give you most of the points. Okay. That makes sense? You make some small errors, but you know the process. I mean, if you show some process,
Like my process was here.
show me. I mean, if it's legit math, that's fine.
I just- Play with that. What do you want?
You can show less. I would want just one additional step. Show me just this line. And then here to here. That's it. Those three would be good enough. Yours is I like it, but I want some more. Okay. All right. That's 8.2. Let's move on to 8.3. This time is subtraction, so it'll be the signs will get a little bit more complex, but the rules will be the same. But now you're gonna see like double negatives and stuff. It's similar. Subtraction with real numbers. So additive inverse. The opposite of a real number is called its additive inverse. So this would be the blank spot. The sum of a number and its, should I phrase that? Oh yeah, there it is. Additive inverse is 0. So this is the blank spot. Symbolically, this is what they mean. The 2 L's? No. Symbolically for any real number A. A plus negative A is equal to 0. That's all. That's all this is trying to tell you. So this definition on the right basically says if you add something with its additive inverse, they cancel out. So 2 plus a negative 2 is 0. That's what this means. Okay, nothing crazy. Okay, this is the definition. Subtraction. So for any real number, numbers A and B, the following is true. This goes in the blank spot. A minus B is equal to A plus a negative B, which we kind of already, we already know that, right? We saw that. It's a weird A. In words, to subtract B from A, add the opposite. Of B to A. This is the blank spot. Number one. To find the change in value between two numbers, take the n value and subtract the beginning value. So the blank spot is right here. Symbolically, change in value is equal to n value minus the beginning. I'll just put it down here. Okay. All right. That's all the notes for the beginning of 8.3. Okay, so it says a jet pilot flew her plane from an altitude of 30,000 feet to an altitude of 12,000 feet. What was the change in altitude? What was the difference? Yeah. Kinda, yeah. Yeah, it will be. It just depends like how we want to think about it, but the number's right. So it says the end value minus the beginning value. So what was the end value for that example?
Wait, what?
What was the end value?
There's you little thing, little thing for 30,000 feet.
They started at 30, right? This question started at 30,000
And value is 12,000.
and went down to 12. So the end should be 12,000. Let me write the note here. It says to do end value minus beginning which is equal to the change. So end was 12,000.
The changes 28,000. Wait, sorry, go back.
Right, so here's my end. Beginning was 12 minus 30.
18.
18. Positive or negative?
Wait.
Okay, 18.
It's okay. It's okay.
Wait, you don't put, negative. Oh, it is 18. Oh. Right, never mind.
Let's read the question one more time.
No. 'Cause I thought you were gonna put that over the negative.
Yeah, so the change is negative because we went down. Right? Where are we? Well, we are at 18,000 feet. That's the location we're at, but they want to know what was the actual change. So our change is negative 18. Does that make sense? So this means, in plain English, the plane descended 18,000 feet because it's negative 18. Any questions on the first example? Okay. So what is what is this one?
Negative 11.
Yeah. That'll be negative 11,000.
Negative 11,000 feet.
Mhm. Any questions on that first example? Is it okay? This one or the one in the book? For the next one, I guess. Okay. All right, let's do the true or false. The sum of a number and its additive inverse is the number itself. Is that true or false? Now, if you add the additive inverse, what happens? Like, what is the additive inverse? All right, so what's the additive inverse of 4? So it's just the same number, just it's opposite, -4.
So.
So it's true.
So if you add them together, what is 4 plus -4?
-3.
Whenever you do an additive inverse,
So it'd be 0.
it will always be 0.
Oh, they said -4.
Come on.
-4 plus 4. 4 plus -4. So, do you get itself?
So it's true.
Is it?
It's false because you get 0.
Yeah, it's false because it's 0, not the same number. Okay. Is number 2 true?
Yes.
Yeah, that's true.
The inverse of a -7 is 7. Yeah. Number 3. Yeah, I mean, I guess it's accumulating things, right? It's getting bigger. True. Number 4. 15 minus 7 can be thought of as 15 plus a -7. Is that true? Is that the same thing?
No.
But
Yes.
it
Oh, yes,
depends on.
that's true.
It's true. 15 minus 7 is the same as 15 plus a -7. Okay, so instead of subtracting, you can think of it as instead of losing $7, I'm giving you $7 in debt, right? So same thing. Okay. Okay. So try out the practice. Do 5 through 10. And then I'll work them with you.
Is there? The fraction we got to do it like.
They're already the same. The denominators are the same.
Like, do we do it like the other one, or do we just? Adam?
You don't have to do any extra work because it's already set up for you. Like if you break down the 15, it's already the same factors. So there'll be nothing to do. So just subtract the top. You see what I mean?
I don't want to.
Yeah. But that reduces though.
He wants to simplify.
Yeah. Simplify. What'd you guys get for 5?
-11.
Yeah. What about 6?
3.4. Yeah.
Fit there. -11 and 3.4. Oops, there it is. You guys get 3 for 7.
Oh, good.
19.
Yeah, that's good. Negative 8 plus 11. That's all I got.
Yeah, if it was a plus in the middle, and you're just adding 2 negatives, then
That's good. What is- what kind of 19 did you get?
Yeah.
Is that a public thing?
Yeah.
You did? Did you? I'm sure you did that. Do that again. Chris.
so whenever you see double negative, it's best to just switch it. Switch it to positive. So this will become plus 11. Then do what we learned in 8.2. The same rules. Okay. Any questions on any of these so far?
Oh, I was right again. You liar, bro. Bro, I knew it's, I knew I had more than
So you guys good on 5 and 6? 7's all right. Any questions on the fraction? Yes.
Five, yeah. But 5 will be 15, that's something.
Yeah.
Wait, so what if we put it like? Okay, like in the test, right? Say that, if we put. If it would have been 5, over 13, it was gonna be the correct.
I'll give you some points.
Oh, that's 16.
Yeah, because you do need to know how to reduce, even though mathematically they are equal. But that's not what I asked.
So you're simplifying that, right?
Yeah, reducing or simplifying, same thing.
You always make that.
Yeah, if you can do it. If you don't, since this class is about the basics, you will lose points or something like that. Okay. Okay, you guys cool on 8?
Good. Well, I'm trying to get a.
Okay. Wrote that weird. So -6 plus a -4. Number 9. Yeah, this will become, so you just add them and keep the signs. Right? And then same thing, right? Nothing, not too bad. What's -11.3 plus 5.3.
6.3.
I just got -6. See, that's good. See, okay.
Then I got it.
What do you do?
Hey, be nice, guys. That's cool, man. I admire the passion.
Because it's gonna make me like second myself.
It's gotta be confident, man. And that's why we're here, right? Gotta build that confidence in math. What's this gonna be? Yeah. All right. Try 11 and 12. I think that might be it. Oh no, I'm stuck. Excuse me. The time doesn't really matter, right? For number 11. It says the ending temperature minus the beginning, correct? What is the ending temperature?
58.
The beginning,
76.
all right. You subtract them.
I got
Negative what?
This, remember what I said? I couldn't have my negative right here.
Yeah, that sounds right. You guys agree with negative 18? Is that wrong? Minus 70 and negative 20 minus. Negative 22. Or am I seeing things? You all agree on negative 18? Yeah. $58 minus 76. I don't know if I have it. Let me see. Yeah, it's true. It's right.
You can work backwards. So wait, -8 is Fahrenheit, right? Does that incorrect?
I mean, you can work backwards. It should be like
58.
plus 18.
It says you're working.
Yeah. You're right. No, it's right. It wasn't making sense in my head for a second.
I would work backwards. Picture.
Yeah, that makes more sense. For a moment, it just messed with my head. But it's nothing wrong with it. It's nothing wrong with it. I'm just crazy. Okay. All right. Go for the. What's number 1? On the additional exercises.
Number one is negative 148, right?
That one's not too bad, right? Number two, what's the difference?
-8. You know, 300 less.
No. Number three. Which one is bigger? Or are they equal?
Side on the left side is, the left side is greater than the right side, right?
Think so. Let's see.
No. It's a negative. So that's negative, it's bigger.
What happens with that double negative?
Yeah, positive.
And over here, what do we get? Becomes more negative, right?
Yeah. Negative. Oh, sorry.
So which one's bigger?
The left side, is that right?
Yeah. Okay. Let's use the rest of the time to work on your homework. 8.1, 8.2. I'm sorry, 8.2, 8.3. Okay. Let me check the